Hello everyone, my name is Hitesh. Nice to meet you all. I work in Tools for Software Engineering Group at Microsoft, which is now renamed to One Engineering Systems. My work revolves around improving engineering tools and processes. Related to that, I'm going to talk about some of the things that we are doing at Microsoft to monitor and optimize your engineering loops. We'll get to that term in a moment. At a very high level, conceptually, software development is about materializing abstract ideas into something tangible that would add value for our users. This value add could be in the form of a new product, new feature to an existing product, or bug fixes to known issues. Given that model, your objective would then be to minimize the time it takes from idea to creation so that you could optimize your software delivery. If I may ask, please hold that view in your mind for the rest of the talk. To set a bit of context, right, let's take a peek into key phases of software development, modern software development. Usually there is a team planning phase for a given sprint, which leads to a prioritized backlog of items that need to be accomplished for that sprint. Then engineers pick up the task, they code, build, and test. Once they are happy, they open up the work for the rest of the team to look at in the form of a pull request, usually nowadays. There is some back and forth. Developers iterate over the feedback. Once everyone is happy, they get a sign off. They complete the PR, merge the code into master, wherein more validations kick in. And finally, you create a release to produce an artifact and then deploy that artifact into various stages of production environment, which would finally add value to the customers. If you look at the left-hand side of this process chart, you will notice that code, build, test is not a sequence, but more like a loop, as you never get it right the first time, but you iterate over what you have locally tens and tens of time, and finally arrive at a working solution, right? So this is more like a loop. So something like this is a more appropriate representation of a process, right? You code, build, test, debug, and you keep doing that until you achieve what you intend to. Similarly, you'll get feedback in this process from your developers who are in the team, which would result into something that you might have missed and would lead to more iterations. And then there's a validation, release, and deploy phase following on. This local loop of code, build, test, debug is something that I call inner loop. So it is an iterative process that a developer performs when they write, build, and debug code. Of course, there are other things that a developer does, but this is a tight set of steps that are performed over and over before they share their work with the team or the rest of the world. Every developer working on a team runs that loop several times a day. And the experience for developers who are working in the same team would be more or less similar because they are on same tooling. It is also true that the steps in your inner loop could be different depending on the kind of work you do and the tools you use. Exactly what goes into a developer's inner loop will largely depend on the kind of technologies they are working on and the tools that they're using, of course, based on their preferences as well. So for example, if I was working on a library development, as you can see on the left-hand side of this slide, my inner loop would include coding, building, test execution, and debugging with regular commits to my local Git repository. On the other hand, if I was doing something more familiar with web front-end development, then I would probably optimize around hacking on HTML and JavaScript, bundling and refreshing the browser, followed by the regular commits. At Microsoft, C# developer experience represents a big portion of this pie, so we would focus on that. Going further, actually, to understand a little bit more about the inner loop, the steps within the inner loop can be grouped into three broad buckets, experimentation, feedback collection, and tags. So if we flick back to the library development scenario that I mentioned earlier, coding could be characterized into experimentation because that's where you turn the abstract ideas into something more tangible. Building and testing are more on the feedback collection side, and committing is text. So of all the steps in the inner loop, coding is the only one that adds real customer value. Building and testing code are important, but ultimately we use them to give developer feedback about what they have written to see if it actually delivers sufficient value. For example, does the code even compile? Does it satisfy the requirements that we agreed upon, and so on? Putting commit in the tax bucket is perhaps a bit harsh, but the purpose of the bucket is to call out those activities that neither add value nor provide feedback, but they're necessary. So for example, committing code is necessary for it to be part of the rest of the pipeline. However, if the tax work is unnecessary work, it should be eliminated because it's a waste of time. Having categorized the inner loop, the steps in the inner loop, we can now make some kind of high level objectives. The goal should be you want to execute the loop as fast as possible, right? And the time it takes for the loop to execute should be proportional to the changes you are making in. At the same time, you want to minimize the feedback collection time and maximize the quality of the feedback that you get. Similarly, you want to minimize the tax you pay by eliminating where it isn't necessary to run through a particular loop, right? You want to remove all those unnecessary steps. As new code and more complexity is added to any code base, the amount of outward pressure to increase the size of the inner loop also increases. More code means more tests, which in turn means more execution time and a slower execution of the inner loop. If you've worked on large monolithic code bases, it is possible to get into a situation where even a small change requires a disproportionate amount of time to execute the feedback collection step. This is a problem, and one should fix it. What I'm going to do is switch gears a little bit, right, and bring back this picture so that we can concentrate on the other side of the spectrum of the inner loop, right? So once you submit a PR, there is a transition of the workflow from the inner loop to the outer loop. That is the right hand side of this circular loop that you see. That's where the outer loop comes into picture. The goal of the outer loop is to get the committed code out to production. Because a feature is not really finished until we have successfully deployed it to our consumers. As you can also see, the outer loop also includes a lot of text, such as code reviews, scanning processes, scan for secrets, or at the same time, have code coverages and so on. You want to also do signing process, binary signing, as part of your compliance. And then, you'll have a lot of approvals with respect to the release pipelines. So you want to be cognizant of how much and how often do you want to basically pay those taxes. You don't want to pay the tax every time you add a method in the code base, and you would want to probably bundle a lot of logical pieces together that add value so that when you run through the outer loop, it is actually valuable to the customers as well. Right. So to recap things a little bit, yeah, these are the same phases that we just talked about. The outer loop consists of code reviews, scanning and binary signing and so on. So to tie things together, right, in order to move faster from ideation to creation, you need to optimize for your loops, right? I mean, the inner loop is something that would help developer to be more productive. The outer loop is something that would enable the work done by the developer to be more efficiently pushed out to the deployment environments. But at the same time, you can't optimize what you can't measure, right? So which brings us to the question of what should we measure? We found these 4 metrics to be fundamentally useful in kind of solving this problem, right? So lead time for change, which is essentially, kind of tackling how long does it take for a code commit to successfully run into production. This is the Uber level metric, right? As you can see, this cross-cuts both the loops. It also includes in some sense of how good is your engineering acumen of the team, and also the planning practices. Are you breaking down the work items into smaller chunks, for developer to quickly basically get them into production, or are those work items kind of too large to incur kind of some sort of cognitive overload on developers? Similarly, time to restore a service, the second metric, measures when things go wrong, how quickly can you restore? In some sense, it is more fundamental to the efficiency of your loop, because usually you revert the changes or apply a hot fix when something kind of is going south. So it is not really exercising your team planning or engineering acumen, but rather the health of your loops. How quickly can you get that change into the production environment? Similarly, deployment frequency is how frequency you deploy to production environments. Keep in mind that unless you deploy, you're not providing the value of your hard work to your customers. So it's important to keep a check on this. The last one, change failure rate, acts more like a quality control measure. You may be iterating really quickly over your loops, but most of the time you may end up kind of rolling those changes back because they are causing bugs. So to provide a more holistic view that not only you are moving fast, but also you're moving in the right direction. That means you're making those changes, you're making those high quality changes. You're not just basically focused on getting those changes faster to the customers, but also focus on adding quality value to the customers. So essentially, these four metrics, the whole idea is to kind of accelerate the speed and confidence of feedback between customers and developers. How quickly basically can we turn that idea into execution, and at the same time let our customers use it and provide kind of feedback, and then we can quickly iterate over that again. So lead time for changes is the Uber level metric, as I talked about, right? And it's good to give you insights, right, where you are with respect to your pipeline. But at the same time, in order to kind of have some sort of actionable insight and kind of identifying the bottlenecks, you wanna basically open that metric a little bit more. You're gonna basically see what are the various micro milestones in this entire pipeline, so that I could get more insights and identify the bottlenecks. So for example, if you look at the time to first commit metric, right, it talks about how long does it take after the developer picks a work item to actually start pushing the commits. If it is really long, it's probably a signal of kind of badly broken down tasks. Similarly, how long does it take for us to kind of build and test locally? If they're in hours, you can't expect developers to deploy in production every day. So your build time and test execution time is very critical. Similarly, for the outer loop, right, once the pull request is created, how long does it take for the rest of the team to look at it? If there is no defined process or guideline, the pull request could be open for days, if not several hours. Because then nobody's looking at it, and unless you get a sign off on your PR, you may not be able to kind of merge it into the master. So if you think about it, it's not really a tooling issue here, but more of a process or cultural issue. Nonetheless, the question you could ask is, how can I use tools to overcome that, or can I? Again, as you see, like, there are other places where you pay tax. Examples, scanning tools like credential scanners, code coverage, and other policies that may be configured on your code base. You would want to look at what are those key places where you end up spending a lot of time, and can you save that? So once you open up the lead time for changes metric into these micro milestones, right, you could look at the time spent in each of these smaller buckets and then try to optimize for efficiency around those buckets. Having gone through that exercise at Microsoft, we've made some great improvements to our feedback collection phase specifically. For example, we've made terrific improvements to our build and test execution phase, where for a lot of teams, we've made that time from days to hours. And this is because now we build and test all in cloud, right? And we only build what's changed, and that too in a very distributed manner. So that has helped us slash down the build times and test times to a really great margin. Similarly, flaky tests, are test cases that fail not in a non-deterministic way for non-obvious reasons. If you work in large code bases and code base which interact with like a lot of dependencies and services around them, right, it's a very critical problem. Every now and then you will see basically test cases failing without any obvious reasons, and those would actually fail your entire pipeline. So what we have done here is we've kind of created a flaky test management system that would identify those test cases by looking at their historical executions, bring them out of the workflow, file a bug against the owner of that test case, and bring the test case back once the fix is deployed. So what happens is you don't end up basically killing the build and the test pipeline because of flaky test failures. On the outer loop side, very recently we've brought in a feature in our engineering system which would nudge a developer, by sending him a ping or or kind of an email if the pull request is not reviewed or open for a while. So look at this. If you look at this figure, you can see that I created a PR which was already approved by Birendra Acharya, as you can see the yellow highlight over there. But I forgot to close this PR for 9 days. So this bot, which is called Nudge, right? It gave me a kind of nudge, literally, saying that, hey, my PR is open for 9 days and I should probably take appropriate action. So what happens is essentially you're trying to reduce the time it takes for this change to be deployed in production so that this could add more value to the customers, right? Similarly, we have created continuous deployment triggers. Very often you'll see in large teams that you've iterated through a loop. You basically bring your change in master, it gets verified, validated, approved, everything, but you forgot to deploy it, right? Just because nobody's kind of deploying on a fixed cadence. So we've created automated triggers to reduce the deployment latency. That means like every single day at a given point of time, the deployment would take the master and basically create an artifact out of it and start pushing it out to production stages. As a result, you don't miss adding value to your customers just because, hey, somebody forgot to pull the button, right? Similarly, there's something called as continuous deployment trigger. This is especially important for teams which are having smaller code bases, right? So they could have the luxury of deploying to every single push in the master. Whenever there is a push, this would trigger on its own, and it would take those changes and start deploying it into stages into the production deployment, right? The goal of this presentation was to give you a very high-level overview of what engineering looks like at Microsoft, and also present a teaser of how we are addressing some of the challenges in optimizing our loops. While we've come a long way, I also want to acknowledge that there is no silver bullet to ensure that your loops doesn't start slowing down. It is a continuous process where one needs to pay attention to understand what's causing it and how can one address it. Ultimately, how you build, test, support code reviews, and deploy will all impact how productive your developers are. And I can't stress enough the importance of having the right telemetry. Without it, you are flying blind. Thank you very much.